Regenerative medicine uses 3D printed materials to create and restore tissues and organs. But these 3D printed materials can have microscopic manufacturing flaws that jeopardize the safety and reliability of these products. Callie Higgins is a material research engineer at NIST who pioneered a technique to detect and fix those flaws. Callie, welcome to the program.
Thank you so much for having me.
So tell us, if you will, in a non-technical way, about the technique that you created to help scientists and engineers to detect and fix those microscopic flaws.
Oh, awesome. Yeah. So for those of you who aren't familiar with 3D printing, it's a technique that uses, for ours, we use light to solidify liquids. And it's done in a layer by layer fashion. So you have your desired structure and then you shine light in a 2D fashion. And then you iteratively build up a three-dimensional structure by moving up a given platform until you have your full part. And what's interesting about this fabrication process is that every single layer has this gradient in material properties or a gradient in mechanical properties, and at one interface at one of these layers it's very, very stiff, and at the back end it's very, very soft, think like a rubber. And so you can imagine that if you're trying to connect rubber to, say, glass, it won't really connect that well. And so those little interfaces can cause a lot of issues with this, if you're trying to put it into, say, a knee or a hip replacement.
So what impact has your work had on the medical field?
Yes, so we actually are currently working with 3D Systems and United Therapeutics to help them build out an interface to understand how to print an artificial lung. And so it's helping inform the development of new materials and new techniques to actually fabricate and replicate living tissue that can then be put into humans.
I mean, so when we talk about being able to print human tissue and organs, I mean, how far away are we from that? How far away are we from, being able to print a lung?
That's a really great question. If you had asked me maybe 5 or 10 years ago when I was starting out, I would have probably been like, oh, we're about maybe a couple decades, 30, 40 years. But with the pace that industry is really helping push this whole field, I mean, I think that we're probably on the order of single decades now, so maybe 10-ish years. I mean, just working with United Therapeutics and 3D Systems, it's been unbelievable the pace at which they've been developing their technology. So I honestly, I don't know, because they're moving so fast.
Well, I mean, this would be really a game changer to be able to print an organ. I mean, not having to use a transplant and things like that. That would be amazing.
And same with animal testing. I think that's one of the main areas of use, is potentially replacing a lot of the animal testing, which is I think people have like moral reservations about, but also they're not as effective as models. They aren't humans. And so if we can help inform that, I think that would be a huge game changer for the biomedical field. Specifically, it starts to get into this, bionic kind of, replacement of different organs. We're definitely still not there yet. I want to reiterate, we're not there yet, but that is definitely the biggest area that I think this specific type of 3D printing will have across the United States and potentially the world.
So Callie, what about outside of the medical field? What kind of applications does your work have there?
So we actually are building out a lot of different connections with, the automotive industry has started to recognize the need for, kind of on-demand part fabrication, because there's, I think we're all very intimately familiar with the supply chain issues. So being able to fabricate things in-house, and 3D printing really can afford that new kind of technology. And we, this specific type of 3D printing, which is photopolymer additive manufacturing, it was really, really useful in the beginning of the pandemic, specifically for, printing out these nose swabs and face shield kind of harnesses, and that was one of the areas that were kind of like our moment to shine, because all of a sudden no one could have access to this, but we could just print out a bunch of these. And that was, I think, very helpful for the medical field, and then kind of for the entire U.S. commerce to recognize that this is actually a very valuable manufacturing technology.
So how do you work with private companies? You mentioned a couple of them. They're obviously benefiting from your research and your innovation. How does that work?
Right. So what's wonderful actually about the National Institute of Standards and Technology is that our mission space is to help drive innovation in U.S. commerce through our research and standardization. And so we have, our mission is to engage with industry. And so we're really encouraged to, engage all of our stakeholders just to make sure that the research that we're doing will have impact down the line. And so I personally really enjoy that, because I've always been a big proponent of making sure that everything that I do will actually help somebody or help U.S. commerce down the line.
And I think it's very important, because it's the U.S. government that can do all that basic research and that innovation that will then feed innovation in the private sector.
Exactly. It's like, why are U.S. tax dollars paying for a lot of this research if it's not going to help them down the line? And that's what I'm really excited about, being able to pursue research that will directly affect and help our society move forward.
You founded the Front Range Industry and Postdoc Summit Association. What is that? Yeah, so
in the Front Range, it's an area of Colorado that has a huge density of postdocs and just lots of different government research institutions and academic institutions, lots of different companies. So it's like a hotbed of very, very smart people. And postdocs are this interesting community of people that have finished their terminal degree, so they have their doctorate, but they're kind of inherently transient because they don't know where they want to go. They want to do, they're doing research currently, but it's generally only a 2-year appointment. And there wasn't ever a concentrated effort to help transition them into, these actual positions where they'll have high impact. And so it's been really nice to found this summit. So there's a conduit for industry and different academic institutions to directly interact with these postdocs that are, brilliant, but might not necessarily get the daylight that, graduate programs might give their students.
All right, well, Callie, we'll leave it at that. Thank you so much for joining us, and good luck with your research. Thank you for watching. If you enjoyed the video, give it a thumbs up and subscribe to our channel so you don't miss out on any future Government Matters interviews.